All right, ladies and gents, today we're going to talk about factoring, and specifically we're going to factor using factor by grouping. So factoring method in this list here, number 2. Okay, this list that we have down here is all the different factoring methods. So first one is distributed property. The second one is factor by grouping, which we're going to talk about today. And then we have factoring part 3 using special patterns, which I'm going to show you later on in this first unit. And then part 4 is an alternative method when factoring does not work. So let's get into this. And again, just to remind you, we are factor by grouping here. All right, so we're really just doing method number 2. So let's start with an example A. Factor by grouping will work on 2 types of problems. The first problem it's going to work on is a trinomial that's a quadratic, okay, or quadratic pattern. And I'll dive into those in the next slide. And the other method or type of problem that factor by grouping works with is when you have a 4-term polynomial, like in example A. Okay, so example A is a 4-term polynomial, and we're going to use factor by grouping. I am assuming at this point that you've already tried to use GCF. Okay, remember GCF is always, we want to try them first. Okay, greatest common factor. This guy does not have a greatest common factor, so because it fits under one of these 2 types of problems, we're going to do factor by grouping. So let's do example A. First thing we're going to do is we want to group the first 2 terms together. So we're doing part A. And then we're going to group the last 2 terms. So it looks like this. Group and group. Okay. Once you group, we're going to move on to part B, which says you're going to GCF out each group. So we're going to take the greatest common factor for this binomial and the greatest common factor for this binomial. So the GCF for the first group is going to be x squared, and if I GCF it out correctly, we get this. Okay, what essentially I've done is I have divided by my GCF. Okay, and this is factor by GCF. Okay, so I divided by my GCF there. Now I'm going to do the same thing for the second binomial here. Okay, and I'm going to take out a GCF. In this case, my GCF is equal to 1 because there's nothing common that divides. So I'm going to have 1 x minus 1. Okay, at this point, you want to make sure that when you factor, your factors that are in parentheses, they have to be exactly the same in order to use factor by grouping. Once they're exactly the same, we can continue to factor by grouping by doing step C, which says rewrite the grouping terms in parentheses, or items in parentheses and items outside parentheses. So essentially we're doing this. We're going to take our GCFs, and they go into 1 parentheses, so that's a positive 1, so it's positive 1. And then we're going to take our factors that we got after we divided out, and they become 1 parentheses themselves. And we are completely done, and this is how you do factor by grouping. Okay, go ahead and try example B and C to see if you can follow this method of factor by grouping, and I will work out the problems. So pause the video now and see if you can get these correct. Okay, so I group them together. My GCF for the first guy here is going to be x squared. So it's going to be x squared on the outside. This turns into x plus 5. And over here, we're going to take out a GCF equal to negative 3 because they are both negative terms here. So I have a negative 3 and negative 15. So I take out a negative 3. And that gives me negative 3x plus 5. Careful with your signs. Since these guys match, I can then continue factor by grouping. So I'm going to do step C now, rewrite the grouping terms. Okay, and that is your answer for B. C, group again. My GCF here is going to be x to the third. That's going to give me x plus 1. My GCF here on the second group is going to be equal to 1. And that's going to be 1x plus 1. And then group together. All right. Cool. And now let's go on to some review from im2 using factor by grouping. So we're going to factor completely. Okay. And we got to use some factoring methods from im2 as well as factor by grouping, which I just showed you. So let's go ahead and do example D. First thing we want to look for always when we factor completely is GCF, which is the biggest number that can divide all these numbers. Okay? So if you do the GCF correctly here, our GCF for this is actually going to be negative 3. The reason we did negative is because we do not want a negative in the front. So we're going to take that negative away by doing a negative 3 GCF. So we're going to divide out negative 3 from each of these terms. Okay? So we have negative 3 for my GCF. If I divide negative 3 from 30, that gives me 10v to the second. Negative 3 from negative 69, that gives me positive 23v. And then negative 3 from 126, that's going to give me negative 41. So negative 41 here. Okay, so this will be our final factored form. Move on to example E. Again, looking for GCF first, which we do have a GCF. It's not a number GCF this time, but every term has a common variable. When this happens, you pick the lowest powered variable. In this case, the lowest powered variable is x. So we're going to divide out an x from every term. If we do that correctly, this is what our factored problem looks like with a GCF. So it's 2, and this turns into 2x squared minus 11x minus 6. Okay, once you have this, let me fix the 6 a little bit. All right, we then want to check, because this can actually factor more, and we're going to use the diamond method. And then after that, we are going to factor by grouping. So the diamond method says when you have a leading coefficient here, like the 2, you're going to take the 2 and the negative 6, multiply them together. So when I multiply them together, it gives me negative 12. The middle number goes to the bottom, which is negative 11. And our goal is to figure out what multiplies to negative 12 but adds up to negative 11. Again, this is a diamond method from im1 and im2. So the factors that multiply to negative 12 and add up to negative 11 is negative 12 and positive 1. Once you have the factors of negative 12 and positive 1 in this case, these guys will split the negative 11x. So the negative 11x turns into negative 12x and positive 1, as you can see here. So I have 2x squared from this guy. The 11x has turned into negative 12x and positive 1x. We split the middle term, and then we bring down the negative 6. So again, the 11x has turned into these two. Okay? Now if you notice, my problem now has 4 terms. We can now factor by grouping. So we're going to now factor by grouping. So I'm going to group the first 2 terms together, second 2 terms together, and we're going to factor by grouping. So my GCF here is going to be 2x. If you divide 2x out, you get x minus 6. My GCF for the second group is just going to be simply 1. You divide that out, you get 1 parentheses x minus 6. And since the factors are the same, we can regroup just like we did in the last slide. So it's going to be 2x plus 1 parentheses x minus 6. Okay, and then do not forget your original GCF. It still has to get multiplied to the front. All right, and that's how we get our final factored form. Okay, last problem here. We're going to go ahead and do a GCF. And the GCF that I see, always try GCF first. GCF in this case, for this problem, is going to be 2. So if I divide out 2, this gives me 3n squared plus 17n plus 10. Okay, once we have that, we are going to check if I can do the diamond method here. So the diamond method, since we have a number in front, we're going to multiply the first and last together. That number goes on top. 17 goes on bottom, and we're trying to figure out what multiplies to 30 but adds up to 17. Multiplies the positive 30, adds up to 17, and the magic pair number that you should come up with is 15 times 2. That multiplies to 30, but it also adds up to 17. So now I'm going to rewrite this by splitting what we call the b value, or the middle number. We're going to split this into 15 and 2. So it looks like this. 3n squared plus 15n plus 2n plus 10, and then we're going to factor by grouping. So pair those up. The GCF here in the first group is going to be equal to 3n, and that gives me 3n on the outside with n plus 5 on the inside. My GCF for the second group is going to equal to 2, and that gives me 2 on the outside and n plus 5 on the inside. My factors match, therefore I can rearrange and rewrite. Group the GCFs together, group the factor together. This will be your final answer, but do not forget your original GCF in front. So original GCF was 2, and that's how you do these factoring methods.